everyone. My name is Brett Sherfy. I'm a graduate student at Virginia Tech, and I'm currently in a class that's Math 4644, which is using technology and math. And we've been asked to create a problem using our iPads that we've been given this semester to utilize the camera and just kind of bring real-world problems into the classroom. And I think this is modeled off, I think, of maybe the guy's name is Dan Meyer, but he was another gentleman who uses real-world problems on his blog to engage his students. So the problem I came up with, I was walking across campus, and they happened to have this function this week at Virginia Tech, and they were setting up this stage, and the stage had this giant arch that I guess was, pretty massive, one of the biggest things I've ever seen go up on this drill field. And I thought, wonder how big that thing is, wonder how tall it is. And I thought that'd be a good problem for students to just kind of start making some assumptions and breaking down into almost a engineering method of how you go about solving a problem. So I took this photo, and the photos, it's tough to see it here, but I've adjusted the photo later on so we can see it a little bit better. So go ahead and get started. So here's a zoomed up picture, and very simply I would just ask my students, how tall is the arch? And from there, it's a pretty open-ended question. I didn't ask them, how tall it was in a particular set of units. They could give me the answer in relation to something else. There's lots of different ways that they could go about answering this problem. But I think, just first up, zooming up, you can see the arch a lot better and kind of get an idea. And I think maybe a good question to ask them would be, what's your guess just looking at that photo? There's some reference objects in there that might have an idea of how tall it is, and they can kind of go from there. So I would say, I would give them this question and then say, work on it for 10 minutes and we'll talk about it. And come around and address each table as they're working on it, maybe break them into smaller groups. Some interesting things to note are the tents here. You've got a person walking, you've got these lampposts, and I think the big thing that I noticed was the truck there. And it's conveniently lined up pretty well. So I went ahead and I took this problem and I overlaid a grid on it, and I used the Geometers Sketchpad to just overlay a grid and imported the photo. And then I just created two line segments that I thought were actually four line segments, one for the length and the height of the truck, and one for the half of the length of the arch, and one, basically both of, if we were assuming that it's a half circle, basically both the yellow lines would be about the radius of the circle. So I took those measurements and just kind of overlaid them on there. I think that this was a good idea, just so you get the students an example to say, well, I can kind of take this little blue line here. Let me put a mark here. I can take this little blue line here and, kind of stack it up here and say, well, it goes 1 here, maybe 2 here, maybe 3 here. And just to get an idea of, like how tall this segment really is compared to this truck here. And then they can do the same thing with the length if they wanted to figure out, use that to determine something else. So pretty easy to just bring this photo in a Sketchpad. The next thing I did was I actually took the measurements, and you see the units in centimeters. I think, actually, when I looked at it, it kind of tripped me up. I think it could be a good thing to have there, because students are going to be like, oh no, do we have to convert units? And it's going to be a good test of whether or not they understand what they're doing, the problem. If they're just using the photo to scale, so all they really need is the ratio of what's in the picture, the height of the truck compared to the height of the arch. And when I looked at it, I was like, oh man, I'm going to have to convert this real quick. And I knew the measurement, but I had to think about it for a while, why it didn't matter. And so you would have centimeters over centimeters to, I guess, cancel out. So the units would cancel. And I'm actually while I'm doing this, I'm going to plug in the iPad because it looks like it's going to die. Gave me a prompt that battery was below 5%, so this is part of working with technology, so we should be good to go now, plugged in. So, students could use these ratios to understand how they could figure out the height of this arch. So from here, I just made an assumption. I said I think that this arch, this truck right here is, I think it looks like a Chevy. You could have picked anything, but I said it looks like a Chevy. So I went ahead to Chevy's website, and I thought, this looks pretty similar to what we're looking at. I saw this one right here. I didn't think it was this one because this one says it's a long cab, and when going back to the photo, I didn't really think it looked, long bed. I didn't think it looked like that. Obviously, these have an extended cab, so I said, nope, can't be that one. So put an X over these guys, nope. So over here, of note, is you can just go on the site and find the dimensions. And this image here shows the dimensions. And what we're looking for here, we see that the height overall is roughly the same, so 23.6. And actually, you'd have to scroll down a little bit on the next page to get the overall height, which I think I've highlighted, overall length, which is here. So now they can know the overall length and the height, and just use a simple ratio to calculate it. So what I would say is, they could go back to these numbers and say, well, the overall size of the height of the truck is 1.06, and let's see, GE is 9.24. So if we come over here, we say 9.24 divided by 1.06. If you give me a moment here, I'm just going to use this. So this is 8.71, and that's just simply a ratio. So that, and then that the height of the truck is actually 73 inches. So I can take that, multiply this by 73, not a very good 3 there, and times by 73. So 637 inches, or take this and divide it by 12 inches, and I would get 53 feet. So that's how I would go about solving. And I think you can take this problem even further, say, how long is it? Again, they would just use a ratio of the length of the truck, the centimeter, the dimensions that were measured using Geometers Sketchpad, and then what they found for the overall length of the truck, and go from there. Again, you could also say, what is the length of this arc, and how long of a sheet would you need to cover it. So I feel like the problem, lends itself to being open to different types of investigation. The students might come up with something that you didn't even think of. So that's how I thought of looking at this problem. I just thought it was a good real-world example of take a photo of something, use similarity, make some assumptions, go on the website, find whatever you think this approximate length is or height is, and go from there. So I think it's a good example of breaking down a problem systematically that basically has no scaffolding. So thanks a lot for your time, and hopefully this was a good presentation of a possible way to engage students using real-world problems and pictures. Thanks.